before we continue, I really do want to say this again. Just that if you have any confusions, please ask me, because right now it's not going to be too hard. But because it's not too hard, I want this to be like, I want you guys to understand everything about this topic, really. Because we're going to be using these concepts later on, and that's when it gets hard. So any questions, please feel free to ask me. I really recommend asking me if you have any confusions. Okay? Okay, so the important thing I want to say, I think everyone gets the basic concept of multiple. But I think something you guys probably not are familiar with is negative numbers can also be multiples. Because if you look back at the definition, right? It said A is considered multiple of B if A equals B times some integer. Do integers have to be positive? No, right? Integers, any number that's like a whole number. It could be 1, 2, 3, 4, blah, blah, blah. But it could also go the other way. It could go -1. It could go up to 0, -1, -2, -3, all those numbers. So that means you can multiply by a negative number as well. So like 5 times -3 is what? It's equal to, Ryan, what would that be?
That would be equal to
It's just 5 times 3 and you have the negative at the end, right?
Yeah.
So yeah, -15. I know this is an easy question for you, but the reason I asked you this is for this concept. Now, does this mean -15 is a multiple of 5? This is the question I'm asking everyone. Do you think this is true or not?
Yes, it's true.
Yeah, and why is that?
Because if you add 5 to -15, you'll get 5 soon, because you just need to add 5 to -15 4 times, then it'll equal 5.
More with multiplying.
you enter the 5 and a 0.
Sorry?
Call it a multiple of 5. It has to end with 5 and a 0, and it ends with 5, so yeah.
Oh, yeah. Okay, I see. That's the divisibility rules. That's very good. That's the next section. Yeah, but we also saw that it's just 5 times -3, and -3 is a whole number. So then it's a multiple. So negative numbers are also multiples. Very important. And I'll ask you another question. Is 18 a multiple of -3? True or false? Is this correct or no?
Yes,
And why is that?
because
Because
if you take the negative sign away from 3, 18 is
Yeah.
18 is a multiple of 3.
Yeah.
And you just need to.
Very good. You got to the key point there, which is you can take the negative sign away. If you take the negative signs away and they're still multiples, that means the negative signs, numbers with the negative signs are also multiples. Does that make sense? The negative sign doesn't matter, is what it's saying. So very good. Both of you got that. Really good. So now we'll just do some questions from together, which is we're going to check if the second number is a multiple of the first one. So before we only saw the numbers that are multiples. How do we know, like, if like with big numbers, right? Because we can sort of do this in our head. When we have big numbers, how do we check if it's a multiple or not? Do you guys know the way to check the number if it's like a multiple? Because yeah, if it's like 18 and 3, you can do this in your head. But if I give you, something like this, how do you check if it's a multiple or not? And the trick here is long division. Actually, let's do A and B quickly first. Is 12 a multiple of 24? Is 24 a multiple of 12?
Yes.
Yeah. 24 is 12 times 2, yes. So yes. And is 35 a multiple of -5?
Yes.
Yeah. 35, very good, Arjun. Is 5 times 7. And since 5 is a multiple, -5 is also mod. Okay, here's where we can't do this in our head, right? Is 27 a multiple of -6, 22?
No.
Yep, that is correct, but how do we know?
No, because you can't fit, and even you can't fit. Because 27 is not a factor of 622.
Yeah, how do you know that though?
Because when you
Maybe because of like the 7 doesn't like fit into 22 or something.
No, because it's big, it could potentially. When you like go to long division, it might. When it goes to like big numbers, it might get to 22. Like, because 27 can become any number at the end. Because if it's a large number, we don't know exactly. And the divisibility rules aren't clear for big numbers. But I think I gave it away a little bit. The way to check this is with long division. Right? When you do long division here, some of you might not be able to count it, but it's still pretty big to count and it's a bit long. It's easier to do long division. Is you do long division and see if you get a remainder of 0 when you do long division. So for example, here, if I do 2760, so it doesn't do anything, 2762, that's 2754, that's 2 27s. Carry it over, 8. Bring the 2 down. How many 27s are in 82?
3.
3. And 27 times 3 is 81, I think. Yeah. I'm left with 1. How many ones are in 27?
27.
The other way. We one's too small, right?
Yeah.
0.
So short division is not as useful here just because it's hard to get the remainder with short division. We sort of care about the remainder here. So
Okay.
normally short division is good, but here long division is a bit better. Just to find the remainder. Because we're not caring about 23, we care about this one remainder. We want this to be 0, but it's not 0, right? So if not 0, that means the remainder is not 0, that means this is not a multiple. Does that make sense to everyone? Because if it was a multiple, it would divide perfectly and there'd be no remainder.
Yeah.
So that means 622 divided by 27 is 23 with the remainder of 1. That means no, it's not a multiple. Does that make sense? And we can look, I only checked 27 and 622. I didn't check the negative. But if the positive version doesn't work, the negative one also doesn't work. Because they're the same at the end of the day. Any questions with that?
What happens if we get? Actually, it's okay. I figured it out.
No, it's fine. Please ask the question.
Do you know in the top it says in words this can be described as a remainder when you divide A by B? I didn't really understand that thought.
Oh, so another way to describe multiple means the remainder when you divide A by B is 0.
Yep.
That's the concept. That's what we just used here.
Oh, and also it
Yep.
says A equals B times N. N E Z. I didn't really understand that either.
All right. So this means Z means integer. That means N is an integer. This means is a part of integers.
Okay.
So it's basically saying it's a whole number. This is basically that's what it's saying. Because later on in higher level maths, you learn that like if you don't specify what N is, N could be like a fraction. It could be like 0.3 or something, or a decimal.
So it says N is an integer.
Yeah.
So A equals B N. N is an integer.
Yeah.
Okay.
Yeah.
So
Does that make
so the E is an integer and the Z is a.
no other way? Z is the integer,
Yep.
and the E looking thing is it means is a part of.
So fraction.
No. It's like this means is a part of, and that's integer. So it's saying n is a part of integers. N is a group. N belongs to the integers.
Also, what the equation is saying is just that n is an integer.
Yeah, that's literally the whole thing. Yeah.
Oh, okay. Is it the same on the bottom? It says a divided by n equals n. N is an integer.
Yeah, n is an integer.
Yeah, thanks.
Yep, no worries. Okay, so is it clear how to check if the numbers are multiple? Like, if it's a small number, you can do it in your head, but it's a big number, do long division and see if the remainder is 0 or not. All right, that's good. We'll go to just for you to do something on your own. So we'll go over this quickly, just because I know I went over this last week with some of you as well, but we'll do this again, just because I want you guys. I feel like we didn't go over the negatives exactly last week, so I want you guys to be comfortable with negatives. Just you can ignore the negatives, is the important thing. If the positive versions are multiples, then the negatives are also multiple. So let's do these three, A, C, and E. I'll give you guys about 5 minutes to do this.
And we type our answers in chat?
Yeah.
Thanks.
Yeah, but you only need to do A, C, and E. If you finish early, yeah, you do B, D, F. Also, if some of since some of you already probably done this last week, if you finish early, go to the challenge problems and do those. And you can text me any questions about challenge problems on the chat as well. So challenge problems are on page 8, so you finish early. few people have finished, which is really good to see. I really recommend doing challenges because that's when we're gonna use this stuff we learned and in like a real life problem. That's when you're gonna really fully master the concept. So if you finish early, please do the challenges. All right, we'll go through them now. So A, 3 and 16. I think since they're small enough, you can tell that, 16 is not a multiple of 3 because 3 times 5 is 15. That means 16 divided by 3 is just 5, the remainder of 1. Because 1 more than 6, 1 more than 15. Because it's got a remainder that's not 1. That's not 0. That means it's not a multiple, so it's no. All right, and we'll go to C now with -4, -20. You can ignore the negative signs, and then in the end, it won't make a difference. I would just do 20 and 4. 20 divided by 4 is exactly 5. Right? That means, yes, it is a multiple. Oh, I've got some answers. All right, let's go to E now. We're just going to check if -12 is a multiple of -145. Here we're just going to ignore the signs, just do 12 and 145. And if you do long division, right, you can see that 12 goes to 14 once. So it's 12. 12 times 1 is 12. There, subtract 12. 14 minus 12 is 2. Carry the 5. 12, 24. That's 2 25s. There's 2 12s and 25s. There's 2, so 24. The remainder is not 0, it's 1. Since the remainder is 1, not 0, that means it's not a multiple, so it's no. Right? And if you want answers for the other ones, I won't discuss them. This one's yes. This one's yes. And this one's also yes. Any questions with those? No, all right. Well, we'll skip these ones just because we already covered them last week. So if you want to see how we do them, I already recorded it, and so it's up there as well. These are pretty basic ones, but the important one I want to cover next is addition property. Because I've changed I've changed the handout for addition property a little bit just because I felt like it was a bit long before. So we're going to go through it in a simpler way, right? So let's come together, discuss this. So can you guys give me a multiple of 7?
$210.
Very good. Big one as well. It's really good. Another one? Anyone?
140.
Good. All right.
42.
42. All right. We'll actually use 42 just because it's not in the 0, so it might be a little bit more tricky. If 140 would also work. I'm not saying it's wrong, but just because 42 when you add it, it actually becomes a bit harder. So let's do that. So we know that 210 and 42 are both multiples of 7. Right? I'm gonna make a claim. I'm gonna say 210 plus 42 is also multiple of 7. Do you think that's correct to make? Do you think it's correct for me to say that?
Yeah, because 210 is already a multiple, and then if you just add a multiple to it, it'll still be a multiple, wouldn't it? Because 210 is 7 times 30, and then 42 is just 7 times 6, then it'll just be 7 times 36.
Yeah, very good. And that's the key idea. You have 7 times 30 plus 7 times 6. And if you realize the 7's common to both, you can factor it out. And then it ends up just becoming 7 times 30 plus 6, 7 times 36. Which is clearly, 7 times 36 is obviously multiple of 7, right? Because it's 7 times the whole number. I don't really need to know what the number is. I just know it's multiple of 7. Does that make sense? I didn't even check what this is equal. I just used the distributive property to see that it is a multiple. Does that make sense? Please
Yeah.
ask if there's questions. Just because this distributive property might not be as sharp as it might not be in your mind as much. It's been a little while. Any questions about this? Please ask me. Right, this is important, and this is how we do for anything. So the important thing is this is not just for 7, right? We had an example of 7, but we will generalize the idea. Means we're going to see that it works with any number. This is like important theorem, is that if A and B are both multiples of C, then if you add A and B, it's still a multiple of C. So it's a multiple of C. So this is an important theorem. We saw that it works with 7, multiples of 7. We're going to see that it works with multiples of any number. So that if A and B are both multiples of C, if you add up A and B, it's still a multiple of C. Right? How do you think we can prove this? Because I've claimed this, right? I've generalized this, but I haven't said why.
Use substitution and substitute numbers in. For example, you could substitute A to be 210 and B to be 42 and C to be 7. Then we've already figured out it works, so I guess that works.
That is sort of true, but just because it works with one number doesn't mean it works with every number, right?
Yeah.
You don't know if it works with like 37. So we need proofs. A proof would be it doesn't matter what the number is. We can still be certain that it works. So we need to show that it works regardless of the number. So the thing that makes proofs hard is to know why something's true. We actually need to prove it, and to prove it, we can't just use specific numbers because that's an example. So here's a proof. You don't have to know this, but it's good to sort of understand that it works with any number, right? If A is a multiple of C, right? You can write A as C times M. Do you agree? Actually, I'll do C times M. And M is a whole number. M is integer. We can also write less M is this thing with the symbols. Does that make sense? We don't know what M is, but we know M is integer. Could you let me know if this makes sense? Because this is a tricky point. This is important for the proof, is that we know AC times some whole number. We don't know what it is, so we can call it M. But we know it's a whole number because that's the definition of multiple. Multiple means if A is a multiple of C, A is C times some whole number. And M is a whole number is the important thing. Please, if you're confused, please ask. If it makes full sense, tell me. If not, tell me as well. I want to know if it makes sense to you guys. So is that a yes?
Yeah.
Okay, good. And I'm gonna write B is also C times a whole number. We don't know if it's the same whole number, so I'm gonna call it N. Right? I'm not gonna call it M again because if it's M, it means A and B are the same. We don't know that. So I'm gonna call it N. And N is also integer. Important thing. Because we saw that B is a multiple of, it says here, A and B are both multiples of C. N is integer. Or N is an element of Z. Right, either way, they're both the same thing. And then now we're gonna do A plus B. Can we write A plus B with C's? So there's the equation of C's.
Plus B equals C times M plus N.
You were a couple steps ahead, so we'll go slowly, but yeah, you're correct. So we just go like this for now, right? And then, yep. So you cut off a bit there, Arjun.
So I was saying you could do 2C times M times N because C and C are like terms. So if you want to
Close, but not 2C. What do we do here when we had 7 common to both numbers?
2C to the power to 2C squared because C plus
what do we do here when like see sort of like the 7 here, right? 7's repeating. In this example before, when we did this one, what do we do to the 7?
Oh, we just made it the same thing.
Yeah, we factored out the common factor, right?
Yeah.
We took out the C, the distributive property. And it's C times M plus N. It's basically what it.
I thought it would be 2c to the power of 4 because c plus c. Because my teacher told me anything, if something was x plus x would be 2x to the
Yep.
power of 2.
Oh yeah, I see what you mean. But no, x plus x it's not 2x to the power of n, just 2x.
Yeah.
Yeah, but the thing is, we can't do that because it's not x. It's not c by itself. It's c times by m, and it's c times by n. So they're separate terms. So if you c by itself, you're adding them, yep, it will be 2c. But there's c times m plus c times n. So you have to factor them. It's a bit different. The reason we could do this here, there's nothing multiplying x's here. Like if it was x times 3 plus x times 4, right?
Mhm.
X times 3 plus 4, which is 7x. So
Yes.
it's the same idea with m and n.
Oh, I've got a question too. Do you know how you did c times n plus c times n, and then
Yep.
you changed c m plus n? Did
Yep.
you distribute it? Because most of the time you do c times m plus n equals c times n plus
Yeah,
c.
yeah. I distributed it. I used a distributive property. Here, from here to here was distributive property. Because C is in both, so I distributed it into one. And when I distribute it, we get this. It's A plus B is C times this number. Is this number a whole number?
Yes,
Yes, right? Why is that?
because you stated before n is an integer and n is an integer.
Yeah. So when you add them up together, it's still an integer, right?
Yeah.
Yeah, very good. That's the proof. Now we show that for any A, which is a multiple of C, and for any B, which is a multiple of C, if you add them up together, it's still a multiple of C. So it works with any number. Right? So now we're going to see this in an example. We're going to use this property with that we proved it. Now we're going to use it now. We don't need to prove it again. We need to use it now. So we know that if A and B are both multiples of C, then A plus B is also multiple of C. So let's take a look at this example. So it's been given to you. So this is already, you don't need to check it. You can assume it's true because it is. I've checked it on the calculator and everything. So suppose 7776 is a multiple of 18, right? My question to you is 7776 plus 18 also a multiple of 18?
I think yes, because 18 times 1 is 18.
Yeah. We already know this is a multiple of 18 because it's given. So this is good. We just need to check this. And like you said there, Arjun, 18 is 18 times 1. So 18 is also a multiple of 18. Right? Since both are multiples of 18, when you add them together, it's also going to be multiple of 18. Right? So it's yes. It's because 18 is a multiple of 18. So I would like you to write a quick, little sentence explaining why. So the reason there is 18 is multiple of 18. So if you go to B, now we have a new one. So again, if it's yes, give reason why. And if it's no, also give a reason why. So it's been given to you that 14,292 is a multiple of 6. Now if I do 14,292, which is a multiple of 6, we already know that, to 32, is that a multiple of 6 now? So if I add 32 to 14,292, is that a multiple of 6?
Can I tell you my answer or do I type it in chat?
We're just discussing together. We'll type in chat for the next one. So yeah, just say the answer. It's fine.
No, because 32 is not a multiple of 6.
Very good. No, it's no, because 32 is not a multiple of 6. Very good. Right, so that's important. So if we need both of them to be multiple of 6 and 32, if you do 32 divided by 6, it's 5 with a remainder of 2. That means it's not a multiple of 6. That means the whole thing, when you add them together, is not also not a multiple of 6. So that's very good. Yep.
Question, I think.
Yep.
You know, on example 3.1.3, it says what are the 10 smallest positive numbers? Isn't that impossible to do because the numbers never stop?
Oh, what do you mean?
It says what are the 10 smallest, I mean for B, it says what are the 10 largest.
Large is negative.
Yeah, I get it. I get it.
Yeah, okay, good. Yeah, because the negative largest are like the ones that are closest to 0. All right, we'll go to example 3.1.4 now. And I want you guys to do A, C, and E. So it's very similar to what we did here in the example. So I want you guys to do A, C, and E, but more importantly, yeah, they just do it. It's very similar to the last one, but also E is a little bit of a trick, but it's nothing too crazy. It's a little bit more challenging, but it's not too bad.
Do we need a calculator 77,476 as a multiple of 8?
No, it's given to you, so you can assume it's true.
Oh,
Oh, sorry, I've put the wrong numbers here. I don't know why they're different. It should be 77,476. It's a misprint on my part, so yeah, should be this. See, I don't think, yeah, it doesn't matter. I think it's not a multiple of 8, but just assume it is. It's a multiple of 8. Suppose. You pretend it's true. The only thing we need to check is the other number, the smaller number. So yeah, we'll discuss at 9:45.
so I put it in chat.
Oh yeah. Yeah. So another thing I want you guys to do is also, when you don't just say yes or no, also say why, like a sentence like this. So when it's yes, say the second number is like a multiple of 18 or something. And then when it's no, also give an explanation why. Some of you are already doing it, so it's good. E is a little bit tricky, but this is a keyword there.
I put all of the answers in the chat.
Yeah, good. Okay, we'll discuss them now. So we'll see here. Could take a look at A. So I think there was a little error in this, but regardless, just assume this is a multiple of 8. All right, so we're gonna assume 77476 is a multiple of 8. So we're only gonna need to check to see if the whole thing's a multiple of 8. We only need to check the second number, which is 88. All right. So if you do 88 divided by 8, that's 11 with no remainder, because 88 is 8 times 11. That means 88 is a multiple of 8. Therefore, the answer is yes, because 88 is a multiple of 8. So we don't need to check the second number because it's already given to us. We only check this. So we don't need to check the first number, the big number. We only need to check the second number, and because it's a multiple of 8, the whole thing is a multiple. The whole thing is a multiple of 8 as well. Okay, now we'll go to C. We can check 72436. It's given to us as a multiple of 7, so we don't need to check that. We just need to check if you add these two together, if it's a multiple of 7. So we just need to check this number out. 40 divided by 7. Is that a whole number? No, right?
No.
Yeah. Very good. 7 times 5, 35. 7 times 6, 32. It's in between the two. That means it's 5 with some remainder. I think it's 5. Therefore, the answer is no, because 40 is a multiple of 7. Sorry, it's not a multiple of 7. 40 is not a multiple of 7. So because 40 is not a multiple of 7, when you add a multiple of 7 with something that's not a multiple of 7, the whole thing is also not a multiple of 7. So we only need to check the second one because we already know the first one's good. The first one's already multiple of 7. Okay, now we'll go to E. Here is where it's tricky. Because the tricky part is that it's a multiple of 9, but we check if it's a multiple of 18. So from our theory, from the theorem we learned here in the last page, we don't know anything about 9, so we don't know anything about 18. So all we know is that if we add r plus s, since they're multiples of 9, r plus s is also a multiple of 9. We know that part. We know that from the theorem we learned. But we also know that they're even, right? If you add two even numbers, is that even or odd?
Even.
Yeah, good. That means it's a multiple of 2. Because it's a multiple of 2 and a multiple of 9. And 9 is same as multiple of 18. Because 18 is 2 times 9. Right? Does that make sense? We got the 2 from here, get the 9 from here. Any questions about that? Or does that make sense?
It makes sense.
Yeah. But I want you to be very careful, right? If I give you this, right? If I say r plus s, actually, I'll give you another one. So, because we sort of multiply the 2 and the 9 here together to get that it's multiple of 18. What if I said, another example, if I say r plus s is a multiple of 3, it's called, it doesn't matter, it's called number a is a multiple of 3. Also say a is a multiple of 6. Right? I want you to be very careful here. Does that mean a is a multiple of 18? Because 18 is 3 times 6.
Yeah.
This is a little bit of a trick because the actual answer actually is no, we don't know. It might be multiple of 18, but it might not be as well. Right? We can multiply numbers here, it's fine, but it doesn't work here. And the reason for that is common factors. Do 2 and 9 have any common factors? Except 1, obviously.
No.
No, right? Since there's no common factors, a multiple of 2 add new factors that are not already part of 9. Right? But if it's 3 and 6, do they have common factors? Yes, right? 3 is a factor of 3 and 3 is also a factor of 6. So 3 is common factor. When there's common factors, you can't actually multiply it like this. And I'll explain to you why a bit later, but just for now, just sort of take my word for it. I'll explain it later when we get to like highest common factor and prime factorization and stuff like that. That 3, if you have common factors, you can't just multiply them. So I'll give you an example, right? 12. Is 12 a multiple of 3?
Yes.
Yep.
Yes.
Is it a multiple of 6?
Yes.
Yeah. Is it a multiple of 18?
No.
So that
No.
that means this doesn't work, right? Because this must work for everything, but it doesn't work for 12. That means it doesn't work, right? So this only works when there's no common factors. So gotta be careful using this. Like 9 and 2 combined is 18. That works, but 3 and 6 combined is 18 doesn't work. Because 3 and 6 have common factors. So we'll see why for this later when we get to this section called prime factorization. But just gotta be careful with it, right? It's an important thing. All right, let's go to the next section. So we're gonna skip these, but we'll come back to these around 10:30ish. So what we'll do from now on is we'll go through normal content till 10:30 or 10:25, and then we'll do challenge problems from 10:25 to 10:45, and then in the end we'll do the quiz from 10:45. But I think we'll skip the quiz this week. Actually, no, we'll do last week's quiz this week, just because we didn't do it last week. But we are a little bit behind compared to the other class, so I do want to get ahead in content. So we'll see if we're going to do the quiz or not. All right. So, by the way, challenge problems, because here in this class, not everyone's the same level, right? And that's completely fine, obviously. But if you're feeling like you finished the questions early, please come to challenge problems. This is, like I said before, this is where you master the concepts. And these are pretty hard. So if you have any questions about it, please feel free to ask me as well. But do the challenge problems as well. Okay. So we'll come back to this later. We'll discuss this about 10:25-ish. We'll go to the new section now, which is divisibility tests. Here's where we check if number is divisible by another number, but with shortcuts. So we'll define divisible first, right? Divisible is the same as it's basically the same as a multiple. So it's basically if A is a multiple of B, right? It's the same as saying A is divisible by B. They're basically the same thing, right? For example, 15 is a multiple of 5. That means 15 is divisible by 5. Does that make sense? Do you guys know, like, this concept makes sense? Actually, I'll test you. How about you give me something is divisible by something? Can you give me an example?
5 is divisible. No, 15 is divisible by 3.
Very good. 15 is divisible by 3. Any other ones?
14 is divisible by 2.
Very good. Yeah. So hopefully that concept makes sense. It's just basically multiple but written in a different way. There's one little exception though. So I see, I know it's almost the same. There's one little exception. Let me ask you a question. Is 0 a multiple of 0?
Yes.
Yeah. Because 0 is
Yes.
0. Very good. Is 0 times 1, 0 is 0 times 2. So yeah, 0 is 0 times the whole number.
1 times 0 is 0.
Yeah.
And
Exactly. 1 point there. So now, my question is 0 divisible by 0? So, division symbol, divisible by 0.
Yes.
And the trick is, actually, it's no. That's the exception. The 0 is a multiple of 0, yes. But is divisible by 0? No. And the reason for that is, divisible is division. Can you divide any number by 0?
no.
No. Since we're not allowed to divide by 0, we say divisible by 0 is not allowed. But other than this exception, divisible and multiple are the same thing. Is that clear? So they're interchangeable except for very, very specific case. And it's not very common either. We will rarely see this. So as far as all the other cases, multiple and divisible are the same thing. Yeah, okay. Now, we're going to go to the shortcut, which is basically in chapter like part 1, just no multiples. We learn how to check if a number is a multiple or is divisible by another number. How do we check that? How do we check if a number is multiple? If I ask you to check it.
Equal to,
Yep, sorry. Keep going, Sam.
they're equal to the number.
They don't have to be equal. Like if I told you to check, 846 divisible by, let's say, 47. How would you do this? I'm not asking you to do it, but how would you do it? Just tell me the way you do. You don't need to give me the answer.
I would see if it's a multiple.
How would you see if it's
Number.
multiple? How would you see if it's a multiple?
Because normally multiples have patterns, like 5
Yeah.
5, like 5, 0, 5.
Very good, very good. But 47 is not one of those nice numbers, right? So how we do with 47? But you're actually very, very on point. That's what we're going to do next, which is the patterns. It's this section. But you normally do long division. If it's like, just in general, any number, you do long division. You do long division and you check what? Something's equal to something, which is checking if the remainder is equal to 0.
Okay.
Yeah, which is the long way to do it. But your way is actually clever. It doesn't work with all the numbers, but it works with a lot of the common numbers. It's the shortcut. So the problem with the method with long division is it's pretty long. It takes a long time. But for special numbers, like you said, Sarah, we have shortcuts to check whether they're divisible or not. And these are called divisibility rules. Or divisibility tests, right? Divisibility tests and rules, the same, both interchangeable terms. You can call it divisibility test, divisibility rule. They both work. So I've broken them out into these groups because some of them are very similar to each other. So the first group, which is the blue group, which is checking 2, 4, and 8. Right? To check if a number is divisible by 2, what do you need to do?
It has to be equal.
It has to be what, sir?
It has to be equal.
Equal to what? Or do you mean even?
Yeah.
Oh yeah, even. Yes, very good. Yeah, but even more specific, you can just check the last digit, right? For even. Like, for example, if I really give you a really long number like 3, 4, 7, 1, 8, 5, 7, 6, 5, 4, 2. Is that divisible by 2? Can anyone tell me? Is this divisible by 2? So this is this huge number. But to see if it's even, all we care about is the last digit, right? The last digit is even or not.
It is divisible by 2 because the last number is even.
Yeah, very good. And if I did this now, if I added a 3 here, is it divisible by 2 now? Is that yes or no? Anyone? Sorry?
We check the last 2 numbers, or in some case 1. Last number.
Yeah,
But the
just the
last
last.
number is here 3.
Yep. So
So that means you can't divide it by 2. Because then
perfect.
that's just going to become a remainder.
Very good. Last number is not divisible by 2. That means the whole thing is not divisible by 2. So yeah, this one's no. So when we didn't have the 3, it was yes. This part is yes. But with the big number, it's no. Because the last digit 3 is not divisible by 3. Right? And now we go to 4, because 4 is very similar to 2. But instead of checking the last digit to see if it's divisible by 2, you need to check if the last 2 digits is divisible by 4. Right? And I'll explain this properly later, but just for now, just practice it, right? Just you don't need to. I'll explain them if you need to later, but for now, just use it, right? So what I mean by that is, if I give you a really long number, 1, 3, 5, 7, 8, 6, 3, 4, 1, 6, is this divisible by 4? Let's do it together, right? Do you guys think this is divisible by 4? So
Yes.
what do we need to check? Yep.
Yes, you can, because the
It is
last 2
divisible by
numbers have 16.
Yep, very good. Last 2 digits 16. And what do you know about 16?
And it's 4 times 4 equals 16, so it is a multiple.
Very good. Is that clear for everyone? We only need to check the last 2, and like Sarah and Arjun did, 16 is a multiple of 4, or is divisible by 4. Therefore, yes, the whole thing is a multiple of 4. All right. Any questions with 2 and 4? No. All right, that's good. We'll go to 8 next. To see if the number is divisible by 8, we're going to check if the last 3, instead of 2, we check the last 3 digits divisible by 8. So here you might need to do long division just because, but it's still a lot easier than doing the big numbers. If I give you a huge number, like, so let's just use this number again. If I give you the same number, I want you to check if it's divisible by 8.
You can, because 8 times 2 is 16.
Close, but we're not checking the last 2 digits. What does it say? Last 3 digits divisible by 8. If you don't check 16, we check 416. Check if that's divisible by 8. Right? And you can, here you probably do long division, but even that's not too bad considering, like, 416 divided by 8 is not a huge thing to do. Right? We can just do 416 divided by 8 long division. 8 doesn't go into 4 at all. 41 is in 8 5 times. 8 times 5 is 40. Bring the 1 down. 41 minus 40 is 1. Carry the 6. It goes from 16 2 times exactly. The remainder is 0. That means 416 is divisible by 8. Then what do you know about the whole number? Is this number divisible by 8? So the 416
Yes.
is, yeah. Because the last 3 digits are divisible by 8, so the whole thing is divisible by 8 as well. So it's important for 2, it's the last 1 digit, the last digit. For 4, it's last 2 digits. For 8, it's last 3 digits. Right? This is a bit tricky, but yeah. Is that clear? Any questions about that? No, okay, that's good. All right, now we'll go to some easy ones, really easy one. Go to yellow quickly instead of going to 3, 6, 9. We'll go to yellow, which is 5 and 10. A number is divisible by 5 if the last digit is divisible by 5. Or what's another way to say it is last digit is either 5 or 0.
Or 0.
Yeah, very good. Right? So here, no matter how big a number I give you, it's really easy. If I give you, 3, 4, 7, 8, 6, 3, blah, 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 4, blah, 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 8, 7, 6, 5. Is this divisible by 5?
It is.
Yeah. When you take a look at the last digit, that is divisible by 5. So yeah, the whole thing's divisible by 5 as well. Now if I bring the same number down to 10, right? Is this divisible by 10?
Last digit has to be a 0, but it's a 5.
So that means?
It's not divisible by 10.
Very good. So for 10, you can check if the last digit is 0. So the only things allowed is 0. So any other number in the last digit is not fine. So 5 is not 10. 5 is not 0, therefore it's not divisible by 10. Is that clear?
But there's no rules for 7.
7 has a really long rule, which is not that useful. So it's better just ignoring it. And and for 7, the easy way to just do is long division. For now, you can learn the rule. I can tell you the rule if you want later, but maybe we'll go through 3, 6, 9 first. There is a rule. It's not as nice rule though. It's probably like long division is probably a bit easy anyway. But anyway, any questions about 5 and 10? Divisible rule by 5 and 10. Hey Ryan,
Yes.
did you drop out?
Yeah.
Okay, yeah. Did you what did you last hear before you dropped out?
What do you mean?
Or did you drop out just now, or is it like did you miss any content? You think?
Just now.
Just now. Okay.
Yeah.
All right. Fine. Okay, so yeah, we'll continue then. So we've done 2, 4, 8, and 5 and 10. Now we're going to go to the final divisibility set of rules, which is for 3, 6, and 9. And these ones are, in my opinion, probably the trickiest ones, but they're still not too bad. So to see if a number is divisible by 3, we need to check if the sum of these digits is divisible by 3. Does this sentence make sense? Sum of its digits divisible by 3.
Yeah.
You just add up the numbers within. So if I give you like a number like 7, 6, 5,
3, 6, 9, 12.
Yeah.
15. Just have
18.
to add them up.
Yeah. So if I add the sum of the digits here, what do I get? 7, 6, 5, 3.
It can be divisible
Why?
because it's the sum of digits is 3.
Sum of the digits, it's what, sorry?
Sum of its digits is divisible by 3.
That's not what we want though. We want the sum of the digits. So what would be the digit sum here? If I do 7 plus 6 plus 5 plus 3. That would be equal to 7 plus 6 is 13. Plus 5 is 18. Plus 3, that's 21.
21. So it becomes 21.
Yeah. Is 21
And-
divisible by 3?
Yes, you can.
21 divided by 3 is 7. Therefore, it's divisible. Because the digit sum is divisible by 3, that means this whole number is also divisible by 3. That means 7653 is divisible by 3. Does that make sense?
Yes.
Very good. Now if I bring this down here, for 6, for divisibility rule for 6 is where you combine the divisibility rule for 2 and 3 together. Right? So you basically check if the sum of the digits is divisible by 3, so check this. But then you also check if it's even. So check both of these together. So if you come back to the same number, 7653, is this divisible by 3? Is this, sorry, divisible by 6?
Yes.
But remember, we're checking both things. It needs to be satisfied divisible by 3 and even. I agree, it is divisible by 3, but is it divisible by 2? Is it even?
No.
No, so it gets one cross and one tick and one cross. We need both ticks. We need a tick here and a tick here as well, but we only got a tick and a cross. That means this thing is not divisible by 6. Does that make sense?
Yes, it does.
So you're just combining 2 and 3 together. So if I give you another one now, like 7, no, sorry, 7. Let's do 5, 4, 6. Is this divisible by 6? Question for everyone.
No. It has a tick and a cross.
Why is, oh no, tick and the cross, that's for previous number, that's for this number before. What I remember tick and a cross is it wasn't divisible by 2 before. But it was divisible by 3 before.
This new number is divisible by 2, but doesn't have the 3.
Why not 3? What's the digit sum? If I add up the digits, what do I get?
You can. 3 plus 3 equals 6.
No. What's the digit sum equal to? If I just add up each digits together, like 5 plus 4 plus 6, what's that equal to?
15.
15. Is that divisible by 3?
Yes.
That means the digit sum is divisible by 3. That means it's also a multiple of 3, right?
Yeah.
So it's a multiple of 2 and a multiple of 3. That means it's a multiple of 6. Does that make sense? This is a multiple.
Yes.
All right. Any questions with 3 and 6? Nope. All right, that's good. But 9 is what we go to next. 9 is actually not, I think 6 is probably the hardest. 9 is actually very similar to 3. You just for 9, just do the sum of the digits. Instead of checking if it's divisible by 3, you check if the sum of the digits is divisible by 9. So what I mean by that is if I give you a number like 3, 4, 5, 7, 8. What's the digit sum there?
27.
Very good. Yep, 27. Very quick there. 3 plus 4 is 7. Plus 5 is 12. plus 7 is 19, plus 8 is 27. Right? Is 27 divisible by 9? Anyone?
Yes, it is.
Very good.
Yeah, it is.
Excellent. So 27 is divisible by 9. That means this big number is also divisible by 9. Is that clear?
Yeah.
Very good. So that's the shortcut for all the numbers. Now, and I promised before, I can give you 7 if you want. Does anyone want to know what divisible by 7, the rule for divisibility
Yes.
by? All right, it's going to be tricky. So let me just say it slowly. Give me a second. Yeah. So what you do is multiply, it's going to be long, last digit by 2 and subtract from rest of the number. Then you just check if this new number is divisible by 7. New number is going to be smaller, so it's does that make sense? So that's why it's tricky. You multiply the last number by 2 and you subtract from the rest of the number. And you check if the new number is divisible by 3. So I'll give you an example. If I do 434, right? I'm gonna check if it's divisible by 7. I'm gonna double this, multiply the last number by 2. What is that? 4 times 2 is 8, right? I subtract that from the rest of the number, which is 43. I do 43 minus 8. That's equal to what?
35.
Very good. Is 35 divisible by 7?
Yep.
So that means the whole thing is also divisible. So that means this one is also divisible by 7. Right? So that's the divisibility rule for 7. It's not very clear, it's long. So I'm not gonna like test you on it or anything, but I'll just, if you want to know, that's what it is. Right? But generally I'd say it's probably easier just to do long division. All right. Any questions with the divisibility rules? No? All right. In that case, we'll quickly discuss there's some like that there are easy divisibility rules for other numbers as well. And they mostly build up from this basic ones we know here. So for example, there's a divisibility rule for 16. Do you know what that is? It's very similar to 2, 4, 8. So for 2 was the last digit, for 4 was the last 2 digits, for 8 is the last 3 digits. For 16, sorry?
16 will be the last 4, I guess.
Very
because-
good. Last 4 digits. And you'll see why soon when we go into this section specifically. Yeah, and there's also like 18. Actually, wait, 18 I think was in a question, so I might not give that yet. Yeah, let's not do 18 because that's in a question for you guys to do on your own. If I asked you for 12, do you know what that is? Twelve would just be combining the divisibility rules of 2 numbers. Which 2 numbers? You combine the rule for 3 and 4. You check if this is divisible by 3 by doing the digit sum, like this. But then you also check if it's divisible by 4 by checking the last 2 digits, if it's divisible by 4. Then you can see if it's 12 or not. So the other ones, you can form other ones by combining the ones before. But that's something that wouldn't work is 2 and 6 here. 2 and 6 would be something that wouldn't work for 12. Because problem with this is there's common factors. Anytime there's common factors, you can't combine them, like you can't multiply them together to form bigger rules. All right, anyway, we'll go on to some questions now. go to divisibility rules for 2, 4, and 8. So yeah, like we said before, let's quickly go over the divisibility rules again. A number is divisible by 2 if what's the test?
Last one.
Yeah, last one digit is divisible.
Is even.
Yeah, divisible by 2 or even. They're the same thing. Yeah. And what about 4? Four is the last. How many digits?
2.
Yep, good. 2 digits if it's divisible by 4. And 8 would be?
3.
Yeah, good. That's 2 digits, blah, blah, blah. Same thing. It's divisible by 8. All right. Now, we have choice here. We can either go to we can either do examples together to practice this, or if you guys want to, do you guys want to know why this is true?
Want to know why it is true?
Yeah. Okay. So this proof's a little bit weird. So before that, I want you guys to recap this addition rule. Addition rules used in the proof. So this rule we learned here, which is that if A and B are both multiples of C, then A plus B are both multiples of C. A plus B is also multiple of C. So we're going to use that rule. So addition rule, I'll write it again. If A and B are both multiples of C, then A plus B is a multiple of C. It's very important. Okay. So if I write like a really long number, right? Like 1, 2, 3, 6, 8, 7, 5, blah, 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 4, 3, 2, 6, right? From this divisibility rule, is this divisible by 2 or not? Is this divisible by 2? I'll just put 5. I'll just put the numbers there. It doesn't really matter how long the number is, right? We only check the last one. Is 6 divisible by 2? Yes, right? So the whole thing's divisible by 2. So here's the little bit of a trick. Is I'm going to split this number up into 2. This is equal to 1, 2, 3, 6, 8, 7, 5, 3, 2, 4, 3, 2, 0 plus 6. Is this number a multiple of 2?
Yes.
Yes, right? And for the 2, proof's not that hard. It's just pretty obvious, but because any number ending with a 0 is a multiple of 10. And any number that's multiple of 10 is also multiple of 2, right? Do you agree? Does that make sense? Because into the 0, it's a multiple of 10. Actually, this also for the proof, we're gonna also assume we know multiple of 10 rule, right? This is a multiple of 10, you agree? This is 10 times, this number 1, 2, 3, 6, 8, 7, 5, 3, 2, 4, 3, 2. It's just without a 0, it's multiplied by 10. Is that clear? Please, this is a proof, so it's tricky. So let me know how you guys are understanding what I'm saying.
Okay.
Yeah, so far makes sense?
Yeah.
Yeah.
And 10 is a multiple of 2, right? That's 2 times 5. Right. That means if anything that's a multiple of 10 is also a multiple of 2. Because 10 is a multiple of 2, right? Because it's going to be like, this number is going to be 2 times 5 times some whole number. Actually, wait, I won't go through this, but do you agree that this first number is even? So 2 is pretty easy, and then second number is also even. That means the whole thing added together is even, right? So that's not a proof exactly, but yeah, but this is how we're going to prove the other ones. So actually, for 2, don't take the proof, because the proof's not that important. 2 is pretty obvious, so let's not use the proof. Actually, let's do 4. Do 2, so 3, 2, 6. That's too small a number. Let's check the proof. Let's prove the divisibility rule for 4. So actually, I'm going to assume 2 things. One thing, the addition rule. 2 things. We know divisibility rule for 2. Because I think proving 2 is not needed. Proving divisibility rule for 4 is kind of not as straightforward though. So we're going to use these 2 things. We're going to use this knowledge, right? We're going to assume we know this. So if I give you a number like 1, 3, 8, 6, 5, 6, right? If I want to check if it's divisible by 2, right? Sorry, divisible by 4, I'm going to do this. I'm going to split the number into this. 138600 plus 56. My question to you is this divisible by 4? What do you guys think? Yes or no?
Yeah.
Yeah.
No.
So it's not as straightforward, but the actual answer is actually yes. But good on you for giving it a go though, because it is important to sort of understand this part here. The answer is yes, because this is a multiple of 100, right? 1, 3, 8, 600. There's 2 zeros. It's a multiple of 100. Do you agree with that? This is 100 times a whole number. That means it's a multiple of 100, right? Please let me know if it makes sense. This is kind of tricky. Does this make sense for you guys?
Yep.
Yep. All right. And then the 100 divided by 4 is what? 4 goes into 10 twice. 4 times 2 is 8. 2, 0. So 4 goes into 25 times. 100 is exactly 4 times 25. It's 4 times 25 times 1386. That means a number that's a multiple of 100 is also a multiple of 4, because this thing's a whole number. Do you agree with that? This is a multiple of 4. And any number that ends with 2 zeros is also a multiple of 4 in general, because it's a multiple of 100. Is that clear?
Yeah.
Yep.
And by the addition rule, we know the first number is a multiple of 4. That means for the whole thing to be a multiple of 4, this needs to be a multiple of 4, right? So if this is a multiple of 4, and the whole thing's a multiple of 4, that means that if the last 2 digits is a multiple of 4, it would be. Does that make sense? So if 56 is a multiple of 4, which it is, I think it is, yeah. That means the whole thing is a multiple of 4. And if it wasn't, the whole thing's not a multiple of 4. The important thing is 56 is 4 times 14. Let's write that down. 56 is 4 times 14. That means it is a multiple of 4. That means the whole thing is a multiple of 4. But the important thing is that this number, the first number, will always be a multiple of 4 because it's a multiple of 100. So the thing that will depend is this number. If this number was like 53, not instead of 56, then it's not a multiple of 4. But since it's 56, which is a multiple of 4, the whole thing's a multiple of 4. Does that proof make sense? So the first number will always be a multiple of 4, which is like the hundredth part. It would depend on the other number to be a multiple of 4. Right? That's how you sort of prove it. Any questions about that?
No.
All right. So if that didn't make full sense, that's completely fine. You don't need to know the proof. You just need to know how to use it. So we'll use it now in this example. So we're going to check if the following number is a multiple of 2, 4, and 8. So we're going to do all of them. And you're not allowed to do long division. You don't need to do long division. Actually, would probably waste time anyway. Let's just do this one. Is this number a multiple of 2? Let's discuss this.
Yes.
Why is that?
M's is 2 and that's even.
Ends with 6, which is even. Yep, so it's yes. Last digit is even. What about 4?
No, because 9 is not divisible by 4.
Why is that?
Because 9 is not divisible by 4. It'll be 2.25 if you divide it.
Sorry? What do you check for if it's divisible by 4? You check the last 2 digits, right? It's 36. Is 36 divisible by 4? Thirty-six is equal to 4 times 9. So yes, it is divisible by 4. And the whole thing is divisible by 4. So yes. Last 2 digits is divisible by 4. Does that make sense?
Yep.
And what about 8? Is this big number divisible by 8? And how do we know that? You don't need to tell me the answer, but how do we check it? Can anyone tell me how do we check if this number is divisible by 8?
We check the first four,
No,
last 4 digits.
close. It's not 3 digits. Check the last 3 digits and see if it's divisible by 8. So it's not easy because it's a big number, so it's probably easy just to long division. You probably can't do it in your head. Let me know if anyone gets the answer. Is it yes or no? Sorry?
It's not divisible because it'll be 72 with a remainder of 4.
Yep,
One
very
plus
good. Yeah, can you this?
high seven.
76. 8 times 9 is 79. 72. The remainder is 4.
Yes.
So it's not divisible by 4. So, no, sorry, not divisible by 8. Last 3 digits not divisible by 8. That means the whole thing's not divisible by 8 either. So you just gotta check like this. Basically same each time. And then if you go to the next one, which is the next page, some examples for you to do on your own. So I want you guys to do A, C, and E. Yeah, for smaller numbers, you can do without the divisibility rules. And sorry, when I mean division not allowed, I mean you can't divide the big number. You can divide like the last 3 digits, that's fine. As usual, if you want me to check, you can send me through chat to me as well. Okay, very good so far from what I've seen. Yeah, this has been pretty good. So we'll discuss this, and actually we're gonna skip the quiz today just because I want to get finished this section. We're just finishing all the divisibility rules so that for next week we'll be properly prepared. But I will if you guys want to do like a quiz for quick homework quiz, I will upload that as well. Just because that will help you out, but I want to go through finished content. So we'll discuss this now. So we're gonna check 36. 36. Let me just see this. Yeah. All right, 36. Is 36 divisible by 2? Yeah, 36 last digit 6, which is even. That means 36 is even. So the whole thing is also divisible by 2. Yes. And then 4. Is 36 divisible by 4? 36 divided by 4 is 9. So 36 is 4 times 9. That means yes, it's also divisible by 4. Divisible by 4 again. This smaller number, you know, divisibility rules is not that important because, you know, it's pretty small enough. You can deal with it as it is. And then 8. Is 36 divisible by 8? No, right? 8 times 4 is 32. 8 times 5 is 40. So 36 is in between 2. That means it's no.
Which in-class quiz are we doing? Are we doing the 21st October one?
Oh, we're not doing a quiz today, but you want to do it just because I want to finish this content today. So we'll skip that for this week. But I will upload it because for tomorrow's class quiz, I'll upload that tonight. We can do that for homework if you want. On top of the homework. If you want to, like, I recommend doing it just because it'll help you because this topic's important. But yeah, we won't be doing it in class today. Our goal is to finish all the divisibility rules today. So we won't be able to get through won't have time to do the quiz as well. All right. Let's go to C now. We want to go to the divisibility rule for this one. So for C, if it's divisible by 2, actually we only need to check the last one, just 2. So 2 is divisible by 2 clearly, obviously. So that means the whole thing is divisible by 2 as well. So it's yes. Right? And what about 4? To see if it's divisible by 4, we need to check the last 2 digits. Right? 32 is 4 times 8. So yes, again. And then for 8, we need to check what? The last 3 digits. It's 432. And we can check that by long division. 432 divided by 8. 43 goes in 8, 8, 16, 24, 32, 40. That's 5 times. 40. 43 minus 40 is 3. Bring the 2 down. 32, 8, 16, 24, 32. That's 4 exactly. But 8 times 4 is 32. 0. The remainder is 0. The important thing. That means 432 is divisible by 8. That means the last 3 digits is divisible by 8. That means the whole thing is also divisible by 8. So it's yes again. Any questions with part A and C? No? All right. The last number. This thing. Okay. Is this divisible by 2? Anyone?
No.
No. Very good. And that's because the last digit is odd, right? So thanks, Sarah. That's good. And if it's not the 2, do we even need to check 4 and 8? No, right? If it's not even, then it can't possibly be multiple of 4 or 8. So you can check, but it'll be no. But you can just be like, if it's not 2, if it doesn't work for 2, it doesn't work for 4 and 8 as well. Does that make sense? It's an important point. If it's not a multiple of 2, it can't be multiple of 4. Because 4 is a multiple of 2. And if it's not a multiple of 2, it can't also be multiple of 8. So you don't even need to check. It's a very important point that that'll be important later on as well. If that point doesn't make sense, let me know. Okay. That's 248. So that's that done. Now we'll go to 5 and 10 and quickly state them again. Right? A number is divisible by 5 if how do you know if a number is divisible by 5? If the last digit is equal to. Can anyone tell me?
If it has like a 5 or 0.
Yeah, very good, Sarah. Thank you. And what about 10? Numbers divisible by 10 if last digit is equal to?
0.
Very good. Excellent. So the divisibility rules for 5 and 10. They're a lot easier than 248. So we'll just go over them quickly. So for example, we'll go through this example.
We bought the rule for 10. I didn't quite see it.
Sorry?
Okay.
10 is last digit is equal to 0. Okay, we don't need to prove proofs. It's pretty obvious, so no proof there. Okay. I'm gonna check. Determine whether the following number is multiple of 5 and 10. Is this number a multiple of 5?
Yes, it is because it ends with 0.
0. Yes. Ends with 0. What about 10?
Question.
Yep.
You know, because 5 and 10 they had basically the same divisibility law. So would that mean to find if it's a multiple of 2.5, wouldn't it be the same?
You don't have multiples of some numbers that aren't whole numbers because that don't make as much sense.
Okay.
So it's not as like, yeah, because you don't do it doesn't like we don't really do multiples of things like we don't do like multiples of 0.5. We only do multiples of whole numbers. Yeah, but in that if that was 2.5, it would sort of the reason we don't do multiples is based on integers. But the number has to be multiplied by integers, so it doesn't make sense for the starting number to be not be a whole number as well. So yeah, we only do multiples with whole numbers. But if you do 20, it's quite similar to 10 and 5. Yes. And what about 10? Is this number a multiple of 10?
Yes.
Very good. Ends with 0. All right. Let's go to this one. I want you guys to do A, C, and E. Now I'll give you 2 minutes because these are pretty easy. So do this on your own. 2 minutes. Put on the chat if you want feedback. And if you finish early, either do these challenges or the challenges from in page 8 as well. Yeah, these challenges are really good questions.
I put all the answers in chat.
Yeah. Taking a look at them now. Okay, we'll discuss now. So for part A, 85, is it a multiple of 5? Yes, right? Last digit is 5, therefore yes, it's a multiple of 5. But for 10, the answer is no. Actually, sorry, yes. 10, the answer is no, because the last digit is 5 and not 0. So for 10, it's not divisible. So it's yes and no for A. Right? And for C, it's not a multiple. It doesn't end with 5 as 0. That means it's not a multiple of 5. It's no. We can check 10 as well. It's pretty easy to check. It's no, but if it's not a multiple of 5, that already means that it's not a multiple of 10 either. So if it doesn't work for 5, it doesn't work for 10 either. So actually, if it doesn't work for 5, it doesn't work for any multiple of 10. It's not a multiple of 15, not a multiple of 20. None of those numbers will also be it won't be a multiple of those numbers either. All right, and E, which this number, the answer is, if the answer is 0, so it's yes for 5 and yes for 10 as well. Any questions with A, C, and E? Nope. All right. So that's pretty straightforward. So yeah, that's good. So now we'll go to 3, 6, and 9. And this one is the slightly trickier one. So can anyone remember the divisibility rule for 3, 6, and 9? A number is divisible by 3 if? How do you know it's divisible by 3? What's the rule? Can anyone tell me? Even if you're not sure, give it a go. Giving it a go will make you like, yeah.
For 3, if you add up the sum of all of the digits, and if it's divisible by 3, then it's an.
Yeah, very good. What about 6?
Combine the divisibly rule 2 and 3.
Yeah, very good. So we can add them to 2 means 2 is how much divisible by 3, and it's even. Right, or divisible by 2, which is last digit even. It's divisible by 3. So that's pretty. Just combining it. This is probably the tricky one. And what about 9? How do you know if a number is divisible by 9?
The sum of its digits is divisible by 9.
Very good.
By 9.
Great. Digit sum is divisible by 9. And the proof for this one's really, really complicated, and we don't have much time, so we'll just sort of practice it. Even if you don't, I mean, proof is probably one way to remember them is proof, but probably the best way to remember is to practice. So if you practice it now, hopefully you'll remember this even more. So we're going to practice this on a couple examples now. Let's do one together first. You know, I'll cut off some of the numbers. Get rid of this. Just do the small number, because otherwise the numbers get huge. So ignore the first 3 digits. Is the number 23904237 multiple of 3, 6, and 9? And what do you think we should do first here? All the rules require digit sum, right? So we should probably do the digit sum. What's some of the digits here? Two, 3, 5, plus 9 is 14. 0, 14 doesn't change anything. Plus 4, 18. Plus 2, 20. Plus 3, 23. Plus 6, 29. Plus 7, that's 29 plus 7 is 36. So that's our digit sum. If this is divisible by 3, Is this number divisible by 3 then? We know the digit sum now. Anyone?
It is divisible by 3.
Yeah, very good, Sarah. 36 is divisible by 3. That means the whole number is divisible by 3. So the whole number is divisible by 3 because the reason is 36 is divisible by 3. And the next one is, and actually another cool trick is, it's easy to check 36, but let's say you don't want to check that. You can check if 36 is divisible by 3 by doing the digit sum of 36 as well. Digit sum of 36 is 9, and 9 is obviously divisible by 3. So you can do the digit sum of the digit sum as well. If you want to be like, you don't want to do division and stuff like that. If you get like a little bit of a bigger number, you can do the digit sum of the digit sum, and you can still check again. Does that make sense? Because that's a shortcut later on. Because if you get a really big digit sum, like, like 83 or something, you can divide by 3. It's not too hard. But you can also just do digit sum of this. It's 11. Digit sum of 11 is 2. That's not a multiple of 3. That means the whole thing is not a multiple of 3 either. So you can do the digit sum of digit sums also works. All right, and for 6, is this divisible by 6? The answer is no, because yes, we got the digit sum is divisible by 3, but the last digit is 7. That means it's not a multiple. That means it's not divisible by 2. So not divisible by 2. The reason is not 6. What about 9? Can anyone tell me if it's divisible by 9? The answer to it is yes, because 36 is 9 times 4. 36 is divisible by 9. The digit sum is divisible by 9. That means the whole thing is divisible by 9. All right. So that's that. That's the example done. Now we'll do some questions together, but I think I will get rid of this again. You'll need to check this bit because those numbers get big. So you get change this number to 1584207. So do AC and E, but because I think the numbers are a bit too big, so I made it a bit smaller. To do AC and E, and yeah, just send me on chat the answers. So the numbers haven't changed because I felt like they were a bit big before. If you change this number again, sorry. This is the new number. Sorry. So we didn't just do part A, C, and E with the new numbers.
What do you do when we're done?
If you're done, we're nearly time's up, but I would like you to start on the challenge problems. They test the digits in more challenging ways.
How many do we do?
Just start. I think probably even one's gonna take a little while, so just get started on one. Okay. So yeah, time's up. So I'll wrap things up quickly. But I want to say one thing. Just for one thing. Just one thing I want to say is, because we've been just covering content today, we didn't get to do any challenging problems. So at the end of the day, challenge problems are probably like the more important thing for like consolidating everything. If you can get the challenge problems, then you fully mastered it, like I said before. So I really want you guys to, on top of the homework, try complete the challenge problems in this handout. So both page 16 and page 8. What I'll do is I'll upload a recording of me doing these challenge problems of how I do it. So you guys can also see how to do it if you get stuck. I'll give them a go, right? Does that make sense? Just for this week, I'll upload a recording just because we didn't get to do it. Right? So I'll put this on Google Classroom. You guys can see how to do them. Yeah, other than that, we'll just finish up now. I'll just quickly go over the answers. And if you have any questions, let me know. Right? So the answer to A is the digit sum is 9. So and it's even, so it's yes for all of them. And for B, the digit sum is 3 plus 4 is 7, plus 3 is 10, plus 4 is 14, plus 3 is 17, plus 7 is 24. So digit sum is 24. And if I want to do the digit sum of digit sum, which is 6. So this is divisible by 3. So, but it's not divisible by 9. So yes, it is divisible by 3, yes. For 6, it's no because it's odd. And for 9, it's not divisible by 9. So whole thing is not divisible by 9 as well. And for E, you have 1, 5, 8, 4, 3, 6. The digit sum is 1 plus 5 is 6, plus 8 is 14, plus 4 18, plus 3 21, plus 6 27. 27 is divisible by 9. If I wanted to be lazy, I'd probably do 2 plus 7 is 9, digit sum of digit sum, which is 9. And this is divisible by 3, yes. It's also divisible by 9, yes. And it's also even because it ends with 6. So it's also divisible by 6. So it's yes for all of them. Does that make sense?
Yes.
Okay. Yeah. So we'll finish up there. I'll upload the recording. I'll upload the homework tonight. On top of that, I'll upload a recording of the challenge problems. I'll do it right now. I'll record the challenge problems right now, actually. If you guys want to stay for it, we'll finish up now. But if you want, I can do a recording. I'm going to record the class challenge problems right now. So if you want,